Announcements. So today we're going to start Unit 2. Yay! I'm really excited. I like this unit, I think, more than last unit, so I'm excited. It's called, if you want to correlate it to what's in Edmentum, which is where I'm kind of drawing from for my curriculum, is it's called Classify Polynomials and Sum and Difference of Polynomials. So it's kind of like the first lesson from Edmentum, Unit 2. And I made this kind of small, but right here, announcement. If you've turned in all assignments and passed the post test for Unit 1, I should have your grade entered and given to your teacher by 4 p.m. tomorrow. So I don't have it all done at all, but I will be working on it today, this afternoon, and tomorrow. And it should have everything caught up tomorrow. So for those of you who've been working hard and turned everything in, if you're wondering when that's going to show up in student track, I'll be entering grades and telling your teachers tomorrow, by the end of tomorrow. And also, for anyone who's hasn't finished something yet, you still have time. So technically, the month was over yesterday, as we all know. But if you finish something you need to do today, or very last minute tomorrow morning, and you tell me, "Hey, I just finished this. Can you still have my unit count?" Then yeah, I'll finish it, I'll grade it, and I'll get it to your teacher. So we still have today and maybe a little bit of time tomorrow. But if you turn something in super late tomorrow, I won't have time to finish it all for everybody. So let's say today. Definitely, if you finish work today, and give me a heads up, send me a message and say, "Hey, make sure to see this, Josiah. I finished this." I will see it and we'll count it for last month. Any questions, concerns on Unit 1 grading or assignments or anything?
Josiah, we don't have to do the tutorials for them, right?
Correct. Yeah, the assignments are just the list I've been sharing out with you guys each day, and I think I set it out on Remind yesterday to everybody, just as another reminder.
I don't think I have you in Remind.
That is unfortunate. This is Leisha?
Yeah.
Okay. Hang on. I'll make a note. And then later, at lunchtime, I'm going to send you another invite to your phone number.
Okay.
So there's a possibility that the phone number we've got for you in Student Track is no good or not being used anymore. Maybe you have a new number, and maybe that's why
No.
you haven't gotten my invitations yet. But let me see here.
I have the same number, but if you want, I can write down in the chat my number.
Don't put it. Yeah, if you want to just do it privately in the chat, then I'll see it. Okay.
Yeah.
Okay. And I'll try to make sure we get you on Remind today. Needs Remind. Yeah, that'd be great. Send me your number. And anyone else, if you're not getting Remind messages from me, I really want you to add me. So just because that way you can text me, I can text you. You can text me your homework. That's what a lot of people have been doing. So if you want to send me your number privately through the chat here, then I will add you this afternoon. When I send the invite to you folks to add, you have to respond to that text you get from me with yes. And I think it says that in the instructions. So you're going to get a text from some weird number. That's remind.com. It's going to be something like this, 80180, something like that. It looks like spam. It looks like junk. But read it, and you have to respond with yes. And then you'll be added to Remind.
Josiah, it won't override my Remind that I have on my phone with Megan, right?
No, not at all. It should have you in both.
Okay, thank you.
I've got students in multiple Reminds myself, so it should be fine. Any other questions on any of this, please? Okay, anything comes up later, I hope you know what to do. Let me know. I'm always here. If you just text me, email me, call the school, I'm happy to answer your questions. Okay, let's start notes. We're going to be working with what's called polynomials today. Polynomials. So we're going to do a little bit of classifying, and then we'll jump into like actually adding and subtracting them. Uh, and as always, folks, if you have a question, feel free to turn on the mic, stop me, ask your question. It's all good. I want you to. Okay, a polynomial is an expression of numbers and variables that are added or subtracted. It's a very wordy sounding definition, but I think it's a little easier than it actually sounds like it is. So here's a few examples of what we mean by polynomials. An expression of numbers and variables that are being added or subtracted. So something like this: x squared plus 2x. That's this whole thing is a polynomial. Or here's another one. How about like a to the third power plus 5a to the second plus a plus 1. This whole thing here is a polynomial. All right, and I just want to practice this vocabulary again with you. Polynomial. Polynomial. Don't be afraid to use this vocab. Polynomial. You'll be hearing it a lot for the next couple weeks and till Christmas. And notice that in my examples so far, it's just a mix of numbers and variables. So the first one has x as our variable, the second one has a as our variable, and they're being added or subtracted. I didn't actually put any subtraction in there, but these different terms are being added together. So x squared plus 2x, two different terms being added together. And that's what we see with the a example as well. Okay, I'll wait 8 seconds and then we're going to move on to the next screen. If anyone needs more time, let me know. It's okay. Okay, so to classify polynomials, meaning I want to be able to categorize them, I want you to be able to know how to describe a polynomial. And that's the goal here when we're classifying. So here's the three main types: a monomial, a binomial, and a trinomial. And I'm going to underline the prefix of each of those. Mono, you've probably heard other words that have mono at the beginning before. And mono comes from like Old Latin, and it means one, or maybe only or solo. So this basically stands for one. Bi, you've heard this a million different ways in your life, not in a math class, I'm sure. And it also comes from Latin and means two. And then tri, you're probably figuring it out already, means three. So a monomial is a one-termed nomial, I guess, a one-termed item. So here's an example: 4x to the third power. There's nothing being added or subtracted to my 4x to the third power. It's just one item, one term. A binomial is two terms. So that might be 4x to the third plus x to the second. That's my second term, x to the second, and it's being added to the first thing. So this is two terms, a binomial. And then a trinomial, obviously you're following along, I'm sure. That's three terms. So I'm just going to continue my example from above. So let's say we had 4x to the third plus x squared, and then we had minus 10. That's my third term. So this is a trinomial. Now, our polynomials, let me throw that in here. I should have maybe had it here. Polynomial is kind of like an umbrella term that just covers all of these. And poly means many in the Latin, many. So technically, folks, we could say that I guess the binomial and the trinomial are polynomials because it has at least two, right? At least two terms. And then if you had a four-termed item, and I'll make up a quick example to go with this. This means polynomial is many terms. And let's just say we had, I'm going to make up a new example. So like x to the fourth plus x to the third plus x to the second plus x plus 1. This has five whole terms. But the point is, it just has many. So we can generically call it a polynomial. So if you want to be specific, then we want to say how many terms are in the polynomial, right? So that's where the monomial, the binomial, and the trinomial come in. And if you wanted to like be specific about something like my fourth example there, with it has five terms, then what you would call that is a five-term polynomial, because there's no word for five that we're going to use as a prefix. A five-term polynomial. Any questions so far, please? Does anyone need clarification? Monomial, binomial, trinomial. And then we could call them all polynomials. It just means a many-termed expression. We're going to usually just say polynomial, but it is important for you to understand what the difference of these are, because you'll see it in the mastery test: mono, binomial, and trinomial. And later in other math classes, high school or college, they'll be saying these words. So I want you to be ready for that. No questions? Let's keep moving. So here's some important things that disqualify an expression from being a polynomial. So polynomials cannot have variables in the denominator. So for instance, if we saw something like this, a simple one, x squared plus 1 over x, this is not a polynomial. It's because of that x in the denominator, a variable in the denominator of a fraction. That's like a big red light that says, this is not going to count as a polynomial. It still counts as like a math expression. We could still do stuff with it if we need to, but it disqualifies it from being a polynomial. And a few more disqualifying things. Polynomials cannot have negative exponents for variables. So an example is x squared plus x to the negative 1. What does x to the negative 1 mean again? We just did a whole unit on this. That negative 1 exponent means change positions. It's basically the same as my top example, because it becomes 1 over x. And that's disqualifying. So we can't have negative exponents, can't have variables in the denominator, and I think there's one more. Oh, have fraction exponents. So this would be another disqualifying thing, like x to the 1/2. Not a polynomial, not even a monomial technically. It's still an expression, still has value, but it's not going to count for being a polynomial. Any questions, concerns so far? If we see any work like what I have in my examples in red on the right, anything we do with polynomials is not going to like apply to it. These don't count as polynomials. So these are like our big red flags. Uh-oh, not a polynomial. Okay. There's a little more for classifying, and then we'll get into like adding and subtracting polynomials. Actually, let's actually practice just using the vocabulary for now. So we're going to add a little more to classifying in a minute, but right now let's just practice identifying. If you're given a term or an expression, can we identify it as a monomial, binomial, or a trinomial? Here's example one, negative 4m squared times n. Is there anything being added or subtracted to this item? Another term being added or subtracted to this expression that we have?
Is it just one?
It's just one. Who's that?
Jayla.
Jayla, thank you. Yeah. It's just one. So, yes, there's a bunch of things happening here. There's a 4, there's an m, there's actually two m's, right? M squared means there's two m's being multiplied, and then there's a single n, and it's all negative. So there's a lot going on here. However, there's no other thing being added or subtracted. Jayla's correct. It's one item. So this is a monomial. I see there's a third chat. Crap. Okay. Shouldn't check those right now. No worries about being late. Thanks for joining me. I'll be posting the video later. You can see the beginning. All right. Let's look at another one, another classifying question.
Josiah.
Yeah.
So we're counting how many numbers are paired with variables.
We're looking for how many things are being added or subtracted. This here is like one term because they're all being, see how everything in this term is like multiplied together?
Yeah.
And so this counts as one term. There's many items in there, but there's nothing else being added to it. So this counts as one whole term. It's like one bundle, okay? One bundle.
Okay.
So this, if it's all bundled together, all multiplied together like this is, it's a monomial. There's nothing else there added. Let's look at another one to compare it to. Here's my example 2. Same question. Is it a mono, bino, or trinomial? Well, this time we have a term here, and there's something being subtracted, a term here. This is two terms. So we know that this is a binomial. Because,
I have one more question.
go for it, please.
Okay, so if it was just set up like this one or kind of like the last one, without the subtraction, is it still two terms?
Without the subtraction, no.
Yeah.
So if we were to take the subtraction out and like jam them all together with multiplication, like this, I'm going to keep all the same stuff there, but let's just multiply it all together like this. So negative, because the 3 was negative, a squared, 3, and a times a. This is one term, just like example 1 was. So this is a monomial.
Thank you.
Absolutely. Does that answer your question?
Yes.
Okay. Anyone else have a question right now, please? We're looking for, is there like any adding or subtracting? Are they separated by addition or subtraction? Let's look at example 3. Maybe I should have mixed up my examples a little bit. So here's example 3, 5x squared plus 2x minus 1. I look at this and I see one item, another item being added, and then another item being subtracted. This is 3 items, or 3 terms. So this would be called a trinomial. Trinomial. Now, at the end of the day, basically all of these examples are polynomials. Polynomials. We don't see any of those disqualifying things. There's no negative exponents. There's no fractions with the x in the denominator. There's no fraction exponents or radicals. So everything we've seen so far counts as polynomials. And
do they count as poly even if there's one term?
so that's a little tricky. I think because it's a one term, the monomial is kind of its own deal because it's just one. And poly means many. right? So
Many.
you have to have at least two to make many in our world. So to answer your question, no, the monomial is kind of special. It's just a single term,
Okay.
but everything else we'll call them polynomials. Good question. Okay, now I think I've got one more thing to add on here. Oh, you know what? Let's look at this example 4. May as well. Here we have negative 10h plus 5j, different variables, plus 1. Let me ask you guys, what do you think? Is this a monomial, binomial, or trinomial?
Binomial.
You said binomial?
Yeah.
Okay, we're on the right track. There's more than one item here, definitely, right? We've got our negative 10h. We've got our 5j being added. That would be a binomial, but there's something else being added here.
Is it a trinomial?
It's a trinomial because of that plus 1 at the end.
Mhm.
Okay, I guess this is kind of a trick question. I wanted to throw in a different variable. The truth is, folks, we still have 3 terms. So if we want to be specific, this is a trinomial. Thank you both for answering. I appreciate both of you. Trinomial. So I guess the lesson, the takeaway is that it doesn't matter if the variables are different. We will see sometimes equations like this or like polynomials like this with different variables with h and j. They're not not all the same, but that's okay. It still would count as a polynomial because it's not breaking any of the rules, and it's specifically a trinomial because there's 3 items here, 3 terms, 3 items, 3 bundles of math being added or subtracted. Okay, now go ahead and copy down this like format here. Let me read it to you. We're going to talk about degrees of polynomials. So we also categorize our polynomials based on their highest exponent, and that's called a degree. The highest number of an exponent that we see in a certain expression or poly. So so here's the main 3 I wrote down, and then I also put 4th degree to show you. So linear polynomial. These are examples. I'm going to write examples afterwards. So a linear polynomial, oops, just has the highest exponent is just a 1. So I'm going to say for an example, x plus 1. And how do I know it's linear? Like the definition is the highest exponent is a 1. What's the exponent for my x? There's nothing here in my example, right? So technically that's the invisible 1 that we've been using for our exponent work in this last unit. Nothing there. I'll just write a note here. No exponent. So we really have x to the 1. Remember that. And that's where I'm saying my highest exponent is. It's that 1 for my x, linear. If we were to set this equal to like y equals x plus 1, well, that's a linear equation. It's a straight line. And that's where that name linear is coming from. Okay, quadratic has a highest exponent of 2. So an example here would be x to the 2nd power. I'm just going to keep it simple, plus 1. X to the 2nd power plus 1. This is a quadratic binomial. Quadratic is what we call it when it has the highest exponent is 2. And it's a binomial because it has 2 terms. Highest exponent is 2. That's what makes it a quadratic. Okay, a cubic, highest exponent is 3. So x to the 3rd power plus 1. We could call it a cubic binomial. It's cubic because it has a highest exponent of 3. And it's a binomial because it has two terms being added together. And then after cubic, there's no more fancy names for the different degrees. So for if the highest exponent is 4, we would call that a fourth degree. And if the highest exponent was 5, we would call that a fifth degree. So I'll just throw in the fourth degree here. So x to the fourth plus 1. Well, all we can call this thing is a fourth degree binomial. It's got two terms, so it's a binomial. It's fourth degree because the highest exponent is 4. So for all these examples I have up right now, they're all binomials, okay? The linear, the quadratic, the cubic, and the fourth degree, they're all binomials just because I only put two terms being added. What we're focusing on for the degree is what's the highest exponent you see in the problem, in the polynomial. Questions, please. Concerns. Okay, so now I want to look back again at examples 1, 2, 3, and 4 that we already did, and we're going to fully classify them using their degree as well as their mono, binomial, trinomial like classification. I'll wait 10 seconds in case people are still copying or writing. If you need more time, let me know. Okay, so what I'm going to do now is look back at our examples that you've already done, 1, 2, and 3. I didn't change the problems, they're the same ones from earlier, but let's reclassify them using their degree and their size. Okay, so we're going to pick um, mono, bino, trinomial again, and we're going to call it with its proper degree. So example 1, what's the highest degree we see there? What's the highest exponent we see in example 1? Highest exponent is that m squared. So that's the highest exponent is 2. So this is quadratic, a quadratic monomial. Okay, and it looks like I should have made some higher degrees. What's the highest degree for example 2? Well, it's 2 again, highest. So for example 2, that would be another quadratic, but it's a binomial, a quadratic binomial. And example 3, so I'm sorry, I should have changed these and had some third powers and fourth powers or something else. This is again the highest exponent we see. For example, 3 is 2 again. So again, this is a quadratic. However, there's 3 terms in example 3. So this is a quadratic trinomial. All right, and then for that tricky one, example 4, the one that had 2 different variables, well, the variables don't have any exponents shown at all. So it's h to the first and j to the first. So this is actually a linear trinomial because it's got 3 terms. 1, 2, 3. Linear trinomial. Uh-oh, lost someone's connection. Hopefully I didn't lose you all right now with all this vocabulary. So
Just I have a question.
please go for it.
Okay, so we added one exponents because they didn't have any.
Correct.
That makes it linear. That's all you did, right?
Because, yes, because it's the highest exponent for that hj1 is 1, right? The h to the 1, j to the 1. So that's what makes it linear.
Okay, perfect. And then there's three terms, so let's try.
Yes.
Right? Okay.
Correct.
Just gotta
Correct.
process.
Absolutely. Thanks for asking. Yeah, the monomial, binomial, trinomial, or polynomial, that is like a noun, right? That's like telling us what object it is that we're dealing with. The quadratic or linear or cubic, that's an adjective telling you what type. So quadratic monomial, highest term is 2, and it's one item, one bundle, so it's a monomial. And you can compare those different examples there. Any other questions? Maybe we should stop and do thumbs. Actually, I think I want to practice like actually getting into adding and subtracting different polynomials together now. Because I think that's in the long term more important than the naming. However, I don't want to leave you hanging, and there are questions on the mastery test about naming. So I wanted to go over this with you all. So before we move on to adding or subtracting, any other questions on the naming of these things, please? Any confusion, any frustration, any questions, clarifications?
Is this gonna have to do with adding them? Like, is that affecting them?
Well, yes and no. It will have to do with adding them, just to make sure that when we're adding and subtracting them, that we know exactly what should be added together. So that's why I would say yes. It does. It does matter when it comes to adding.
All right, thank you.
Let's jump in. I think people are probably ready. So let's look at example 5. Here we go. Adding polynomials. There's not too much I need to really explain about this except for what I've written here. I want you to scan the problem for like terms. And then we're going to combine each set of like terms. So here's example 5. Take a minute and copy down example 5. I've got negative a squared plus 2a plus 1 added to the next polynomial, 5a squared plus a plus 10. So the two parentheses we see, those are our two polynomials. That's why they're bundled together with their parentheses. Think of it as like polynomial or trinomial, right? Trinomial 1, trinomial 2. Polynomial 1, polynomial 2. And we're trying to add these two items together, these two polynomials. So how do we do this? Scan each one for like terms, and then we're going to add or subtract, depending on the sign, the like terms. So I see negative a squared here. I'm going to underline that with some squigglies, and then 5a squared in the second one. Those are like terms because they have the exact same matching variables, a to the second power, right? So those two can add together. So this is like saying negative 1a, right? Negative 1a squared plus 5a squared. So we're really just adding the coefficients together. That's the number with the variable, meaning the negative 1 and the 5. So those combine to make 4a squared. That's just the a squareds. So now we're done with a squared. Let's try to add a's. I see a plus 2a and a plus a. So that's like saying 2 plus 1. 2a's plus 1a is 3a's. So then those combine to make plus 3a. And then now finally the whole numbers. I've got a plus 1 and a plus 10. So those combine to make plus 11. Done. Scan for like terms. Combine the like terms one at a time. Do your a squareds, your regular a's, then your whole numbers. Pay attention to your negative signs. Any questions on this example 5? Please, concerns.
Do we have to name them after we do that?
We don't have to name them, but you know what? Let's do it anyways because we've spent time on it today, and there's maybe 8 or 9 problems in the mastery test that you might get that do have to do with naming them. So let's name this thing. Highest degree is 2. That's the a squared. So its degree would be quadratic. And then anyone want to help me out with the second part of its name? Would it be a mono, bino, or trinomial?
It's trinomial.
Very good to both of you. Yes. Leja and who else?
Jayla.
Jayla. Thank you both. Awesome. Quadratic trinomial. You're both on it. All right, let's try another one. Number 6. We're just adding the polynomials together. Notice that this time I've got a trinomial for my first polynomial, and the second one is actually a binomial. 3 items added to 2 items. This is a tri, and this is a binomial. Anyways, we're going to treat it the same way as the last one. Scan for like terms, add the ones together that have exact same matching variables, and then you're done. So I've got 2x squared and 8x squared. Those can add together. 10x squared. Notice that the exponents don't add, right? We're just counting up how many x squareds there are. There's 2x squareds, 8 more x squareds for a total of 10. And then I've got 5x and negative x. So that's like saying 5 minus 1. 5x's minus 1x is 4x's. And then our sad, lonely plus 1 here doesn't have anyone to add with on the other polynomial, right? So it's just plus 1. Just bring it down. Don't lose any parts of your adding or subtracting. And that one is done. Naming it, if this would be another quadratic trinomial. Highest degree is 2, and there's 3 terms. So a quadratic, can't spell, quadratic trinomial. And interestingly, let's see, if you look back at the beginning, we had a trinomial and a binomial added together, and it's a trinomial answer. I guess it won't always be that way. It depends on what kind of terms are inside there. It depends if we could like add or subtract this stuff together. In this case, we were able to add them together, and there was one left over, the plus 1. Okay, I'm going to keep rolling because it's already 10:40. Example 7. All right, I put in some more negatives at this time. So we have negative m squared minus 6m plus, next one, negative 4m squared plus 9m plus 2. Scan for like terms. I like to underline them if I'm doing it on paper. And then combine those and then move on to the next set of variables, the different type. So here we're doing our m squareds. Negative m squared minus 4m squared. I'll do this to the side. We're looking at the coefficient and we're looking at the sign. So I read this as like minus negative 1 minus 4. That's the math I'm doing. They're both negative, so they stack up negatively. It's like saying you're short $1, then you're short 4 more dollars, short 5 total. So our answer for the first one would be negative 5 m squared. Then our m's, negative 6 and plus 9. And the space between those is 3. And it's positive 3 since the 9 was bigger. So 3m. And then my plus 2 doesn't have anyone to add with, so he just comes along for the ride. And this is another example of a quadratic trinomial. I should have diversified my examples a little bit, but the truth is, folks, we will be working a lot with trinomials and quadratics. It is where most of our focus will be. So, questions on number 7, concerns. Okay, let's try another one. Actually, I want to get to subtracting. Perfect. So, not too much different here. Difference or subtraction of polynomials. We're basically saying it's one polynomial minus the other. So there's one thing to keep in mind here. I'm taking my first polynomial, the 5d squared plus 7d minus 3, and I'm subtracting the whole second um, polynomial, the binomial 2d minus 5. See that right here? This is subtracting. So it's important to keep in mind the entire second polynomial is being subtracted. What happens with that is that every sign inside the second polynomial, you can think of that as changing its sign. Minus 2d, that's like saying negative 2d, right? Minus 2d. And minus negative 5, I'm going to do this off to the side quick. Minus negative 5, well, this is where we have double negative kicking in. So that negative 5 actually turns into a plus 5. So whenever you're subtracting one polynomial from the other, what I like to do is rewrite it for my first step. You can carry down the original first polynomial. Oops. It doesn't really get changed because it's just the first one that's subtracting the second one. So 5d squared plus 7d minus 3. And now I'm going to go through and rewrite the second one, kind of distributing that minus sign to everything inside. So this becomes minus 2d and plus 5. And while I was at it, I went ahead and dropped my parentheses. No more need for them. And now what we're going to do is just combine all the like terms. So do your scan through, and there's 5d to the second power. There's no other second powers for d. So 5d squared just kind of stays the same. We've got 7d and negative 2d. So that's like saying 7 minus 2 d's, and that'll be 5 plus 5d. And then our whole numbers, minus 3 and plus 5 for a plus 2. And naming it, it's another quadratic trinomial. Really, folks, there's no real difference for like subtracting polynomials. Just wanted to point out that the entire second polynomial is going to have opposite signs because of the minus. So be aware of that. All right, let's try one more together. Example 9. We've got negative 10x squared plus 2x plus 8 minus the entire second one, negative 14x squared plus 8. I like to start by rewriting the second one. So here's the first poly, and I'm just dropping the parentheses. There's no need for them really. And now I'm going to rewrite the second one and also drop its parentheses. So it becomes, see, it's minus negative 14. So that's like saying plus 14x squared. And then minus 8. And now we can start combining like terms since we've like done away with the minus of the second one. So negative 10x squared and positive 14x squared. 4x squared. Okay, there's nothing to combine with my 2x this time. There's only a There's only 2x and there's no other plain old x's, so bring that down, plus 2x. And then my plus 8 and my minus 8 cancel out completely. So here, this time our answer is actually a binomial. This is a quadratic binomial. Any questions on this example or anything else from today? Okay, silence. So I'm assuming everyone's doing okay with this. Go ahead and start your mastery test. Sorry, it's only 10 minutes left, but let's start your mastery tests and see if we can take your first 5 questions and see how that goes. The theme is all adding and subtracting polynomials, plus some questions will be naming them. So they're not going to make you name them every time, but you might get 1 or 2 that do. So we need to be able to name them and then combine them by either adding or subtracting polynomials. So what we're looking at is the first mastery test in Unit 2, and I think it's called the sum and difference of polynomials. Sum and difference of polynomials. All right, I'm going to stop recording now.